Hello, and welcome back to the channel. Today I am doing something a bit unusual. I'm going to be doing a tutorial on how to make an asymmetrical weapon bar for a battle bot. This is the previous weapon for Jellybean, and I'm going to be making a new one because I've been making some improvements to my robot, and I have now more weight to afford to the weapon, so I want to design a heavier weapon. But I also want to redesign it because I think this design was not particularly very strong. It bent very easily against the fight against TS-247. So what I want to do is create a weapon, something like this disc-shaped weapon. You might have seen this before. This is a very common weapon shape. It's quite popular. You may have seen this in the video by Just Cause Robotics. Very good video. It goes very deep into sort of like the science behind an asymmetrical weapon. But in this video, I want to talk about how you can actually go about designing this sort of weapon in CAD. And speaking of CAD, I am using Onshape. Now you are going to need a pretty advanced CAD program for this, nothing like Tinkercad, that won't work. The reason is, blocked by my face right now, but I will try to show it. On this side of the screen here, as you can see, we have mass and section properties. This is very important in order to make sure that the weapon is properly balanced. So you will need a CAD program that has the ability to calculate a center of mass. Onshape is one of these programs, and I would recommend Onshape if you are a beginner because it's free and it's browser-based, so you don't have to download anything. So it's pretty easy to start up, and it's quite powerful, no limitations, and I personally think it's great. Now, as you can see, I already have a weapon designed up here, but I am going to go into the sketches, and I will show you more or less what we're going to need to design this weapon, and then I will design a brand new one from scratch. Now let's go check out sketch 1, which is the main sketch, and it's basically the entire template for my weapon here. I've just shown the top plane so we can see all the lines. Now you can see it's not fully constrained. This isn't a big deal, but over here, the first thing I'm going to talk about is how the weapon mounts onto the motor. Or if you have a pulley system, maybe you're using a vertical spinner, you have to know what kind of mounting system you are using so the weapon can actually connect onto your robot. Now, my weapon has a collet, so it's able to slide around, and this makes sure that when the weapon impacts something that the motor hopefully doesn't break. So it's just a smooth circle. It's very simple. You have to know the diameter if you're using a collet. I have it 32.38. This isn't like super scientific number, it's just what I'm using. But now you can also see sort of what's going on here. We have this massive outer circle, and its diameter is 130 millimeters or 13 centimeters. And this is the maximum radius of my weapon. This is as far as my weapon can go out before it hits, my own robot, because the sort of the front part of the robot sticks out, and the weapon could hit that if it's too large. Now, I do have a little bit of space here. I think it could actually go up to like 135, but I'm keeping it short because you always want to have a little bit of a gap there just in case. And then you can see these sort of inner circles, which correspond to sort of the outer ring of that sort of disc shape. And then these two sort of straight little bar pieces that connect to the head of the weapon. And you can see that it's got sort of a sharp tip here. And of course, there's also this sort of vertical bar shape. This is just a construction line here, but that corresponds to sort of the vertical bar shape that goes through the weapon, as you can see here. And of course, there are fillets. Fillets are quite important, one for reducing the stress on the weapon, and two for the balance of the weapon, because you're going to need to use the fillets to sort of tweak the center of mass to make sure it's in the middle. And the center of mass being in the middle is very important. The closer it is to the middle, the less your weapon will vibrate, and ideally you don't want it to vibrate at all. If you have a vibrating weapon, that can be a very big problem. Now, let's talk about some of the things that you are going to need to know before you start designing your weapon. First of all, and probably the most obvious, is how much weight do you actually have available for your weapon. Ideally, you will have your entire robot designed by now. The only thing you have left to do is design your weapon. You need to know how much leftover weight you have in your weight class so that you will be able to compete, because if your weapon is too heavy, then you won't be able to. Now, I know for a fact that I have about 92 grams available, and it's always wise to sort of take off 1 or 2 grams to make sure that there is a cushion, so in case you do need to make a very small change to something, maybe your electronics, it won't affect you, and also for any scale inaccuracies. So I actually have 93 grams available, but I'm going with 92 to make sure that I am safe. As I mentioned before, you also need to know how you're going to mount your weapon onto your robot or motor. I have sort of this simple circle here, but people might have screws, you might have a pulley system that requires a more complex mounting mechanism, and you will need to know how to design that. You're also going to need to know the thickness of the material that you are using. Most people will use AR 500, and a lot of places that might cut this will only have it in a few certain thicknesses. It won't be variable. You can't make it any thickness you want. So make sure you know what that thickness is, because that's going to put a lot of constraints on your weight, how you're going to have to design your weapon, and the balances and things like that. Now, you also need to know the radius of your weapon, as I mentioned before. How large can your weapon actually be? And the density of the material. AR 500, it's pretty simple. For example, Onshape has a material library. Right-click on here. We can click Edit Material for Part 1. And actually, AR 500 is not in the material library, but you can always use a custom. I just named it AR 500. And the density of AR 500 is 7.85 grams per cubic centimeter. So yeah, there you go. And the density is very important for estimating the weight of your final weapon, so you can actually put it in your robot afterwards and make sure it's not too heavy. Now let's go to designing a brand new weapon. I am going to just create Part Studio here. Okay, brand new Part Studio. I'm going to hide the front and right planes, and I'm going to right-click View Normal to the top plane. Okay, and brand new sketch here. First things first, use circle. This one's going to be 130. This is going to be the outermost circle. That's the final. That's the weapon radius here. And I'm going to make another circle here. This is the inner diameter, and this is 32.28, I believe. Oh, I think there's an extra 2 there. This is the sort of mounting system for my robot, I guess. This will vary from what you're going to do, but as you saw before, I just had a sort of ring of steel around it, and that just goes around the collet. I'm not going to dimension this one just now because there's no need to, but I am going to create another circle. It's going to be the outermost edge of that sort of outer ring, and one more circle is going to be the innermost edge of that ring. Okay. So this is already looking pretty good. We've got sort of the outer ring. I have sort of my mounting system, and I have my final radius where the weapon edge will be. But we need to create some lines now. I'm going to create a construction line here. I'm going to make it horizontal. And then at the midpoint of the line, I make a vertical line. And I'm going to make this coincident with the origin. And now whenever I move this line, these 2 points will always be the same horizontal distance away from the origin, which means that when I add some lines here, oh, this one's not touching it, is it? Okay. Once I add some lines, these lines will sort of form a large rectangle kind of around the origin. I just need to extend them out. Actually, what I'm going to do here, quickly create a coincident and close the shape here with the construction line, and just bring this all the way down here. Okay. So now, as you can probably see, this is sort of forming the middle bar of the weapon. And one more thing we need to do is create sort of those triangular line shapes. So what I'm going to do is create another one of these sort of T shapes. Coincidented over here again. And which outer disk, which circle do I want to use? It doesn't really matter. I'm going to use this one. And what I'm going to do now is I'm going to create some more lines going to sort of the previous edges here. And then we need to create sort of like a rectangular shape. We're going to do another line, making sure it's parallel. The parallel icon showing up there. Just going to bring it down here. Okay. That's nice. Actually, I think the lines need to be over here. That's fine. We just need this one line here to make sure that when we extrude, we don't extrude this whole other part here, and that it just ends. Okay. You can already kind of see the main shape of the weapon starting to form. But now we need to make the edge of the weapon. And this is a little bit trickier. I think these need to be on the same line. Yeah, these need to be on the same line here. Okay. And now I can create another that upside down T shape. And this is just for the very tip ends of the sharp weapon head, I guess. And these are going to be coincidented with the outermost circle here. And then just 2 lines going from here and here. Okay. And now you can pretty much see the exact shape of the weapon. However, there is one major issue, which you can probably see very easily, is that nothing is, actually nothing is dimensioned here. So we're going to need to properly dimension things. I'm going to make this, the spacing here about, let's try 4.75. I'm going to make everything 4.75 millimeters thick. I can make it thinner if I have to. It's a little bit lower, and I'm going to move this. Oh, I might need to dimension this really quickly. Let's say this is 110 for now, just arbitrary value. And we can bring this down. And as you can see, this is pretty much the exact same shape we had in the final weapon. And you can just tweak it around a little bit. And this is where I said sort of having everything fully defined isn't really a big issue, because sometimes you will need to tweak things here and there to get the correct shape and what you want. Let's finish the sketch here for now, and I'm going to start with a extrusion. And I'll select all of these regions here to get the shape of our weapon. Okay, that's more or less what we want. And for the depth, I'm going to choose 4.75 because this is the thickness of the steel I have available to me. Direction, this is all good. I'm just going to click it here. And as you can see, we already have a very nice looking weapon. However, it's not going to be balanced. If we check the mass and section properties here, oh, I don't have a material defined. Okay, we need to define the material. Right-click, assign material, custom AR500, and it is 7.85 here. Okay, that's for the AR500 steel. Now we can check the center of mass. It's actually quite close. Wow. Okay. And it is about 91 grams. Okay, so now that we have the general shape of our weapon, it is time for the long and arduous process of tweaking everything. But first, we're going to hit this thing with some fillets. The fillets, as I already mentioned, are very useful because they will spread out sort of the forces, because the corners, as you may know, are where the stress is going to be greatest. So we don't want any stress on the corners here. Let's start with sort of a medium-sized fillet. Let's try 4 millimeters. This 4 millimeters is quite nice. Okay. Okay, I'm going to do a smaller fillet on these ones because, as you can see, even with a small radius, they are quite big. Let's try 2. Maybe 1.5. Okay, I think I like 1.5 there. Okay. As you can see, we already have some nice smooth edges here. Now, I think I need a fillet here. And I'm going to leave these fillets here for last. Make this one 6 millimeters. These are pretty much arbitrary values, but the last 2 fillets are not going to be. And the last 2 fillets are the fillets that I'm going to use to sort of tweak the center of mass to exactly where I want it. I am going to leave it at 6 for now, though. Okay. And now, as you can see, we have that proper weapon shape. It is nice and smooth with all of those gorgeous fillets. I'm gonna just hide the top plane for now. Actually, no, I'll keep the top plane. I might need to edit the sketch because now, as I already mentioned, it is time to tweak the center of mass to make sure that it is perfectly centered. So first, let's see where it is. Oh wow, it's actually very close. Actually, very close. But the weapon is 93 grams right now. I need to make it a little bit lighter. So I'm gonna hop back into the sketch. I'm gonna edit it. I'll make this 4.5. Should reduce a decent bit of weight. Really don't want to change any of these other ones. To make this 105. Let's see how this weighs. And it's a lot of this where you sort of just do tiny little checks, kind of move it around, see how it weighs. Okay, it's a lot further now from the center, but it is a bit lighter. Maybe let's try 107.5. Somewhere in the middle. Okay, 91.6. It's pretty good. It's a little bit further from the center. I think I can get this centered with about 0.4 grams of extra material. Okay, and here's what I'm talking about getting it centered. Now, because it is symmetrical, sort of on this vertical axis here, the center of mass, of course, only deviates in this vertical direction, where the mass over here and the mass over here can be very different. And that is what I left these fillets for, because now we're going to change these fillets to make sure we can make them bigger or smaller to move the center of mass around. And I just made the fillets a lot bigger, so that means this side just got heavier, which will move the center of mass in this direction. Yeah, as you can see, it did that, but we added a lot of weight, so I think I'm actually going to need to make this a bit lighter. Again, it's a lot of tweaking the shape, it's a lot of tweaking the fillets. I am going to try and go through the whole process of that, but I might have to speed it up because, as I said, this can take quite a long time. Okay, and as you can see here, after a little bit of tweaking the shape, tweaking some of the fillets, and tweaking some other things, I have a weapon that's a little bit lower than the weight I want, and I have my center of mass is quite close. And this is the optimal time to start optimizing those last two fillets here. Now, remembering where the fillets are on our weapon, they're over here in this region, so making these fillets larger will make this area heavier and move the center of mass this way. And as you can see, OnShape actually tells us exactly where our center of mass is. It's just a little bit off, just by 1/10 of a millimeter. But this will still cause vibration if not fixed. So what we're going to do here is slowly make this fillet larger or smaller to try and get this number as close to 0 as possible. So right now, it's a little bit closer down here to the front of the weapon, I guess, to the edge. And this is indicated by the negative number. This is the y coordinate. This way up is y, and this way down is negative. So I'm going to edit fillet 4. I'm going to change it from 10 to 10.1. Let's see what this did. Okay, it only moved a little bit, so I'm going to have to move it by quite a bit more. Try making this 11 millimeters. Oops, that's a slash. 11. Okay, and now the center of mass is too high. So now we have to lower this 10 point, let's try 7. The first few decimal points are always the hardest. It's still a little bit too high. 10.6. Okay, getting there. 10.5. Okay, we're pretty much there. Let's try 10.4. Okay, and as you can see, we were going down by 1/10 of a millimeter each time until we got back to that sort of negative number. And now we know for sure that we need this fillet to be between the radius of the fillet to be between 10.4 and 10.5. So now we just need to do the same thing and dial this value in as precisely as possible. Okay, and this is what we want to see here. Onshape is giving us an e to the -7, which means it's the exponent of -7. And I don't know how many digits it's going to display on other CAD programs, but pretty much once this e pops up, the distance between the center of mass and the center of your weapon is so small and so negligible. Probably what's going to happen is any errors in the manufacturing are going to have more of an effect than the design inaccuracy here. And this means you're pretty much done. And you've got a balanced weapon, hopefully with the shape you want, and ideally with a good mass. Now the mass of mine here is 91.81, which is great because that's pretty much 92 grams. I almost said 92 kilometers. 92 grams here pretty much, which is what I need. It gives me about 1 gram of extra weight for my weapon here. And that is pretty much how you design sort of this triangular disc-shaped weapon, this asymmetrical weapon for an antweight combat robot. But I guess this would apply for a beetle weight. You would just need to tweak your thickness and your weight probably. I think that's going to be pretty much it for this video. If you found it helpful, do not forget to like and subscribe for more content like this. Don't forget to check out the other videos on my channel about the BattleBot if you want to see some cool robot fights or how I designed the robot. And I will see you next time.